In this video, we're going to do the two sample z-test. So we're going to look at two competing floor waxes, and we compared them by doing 20 floors apiece, which with each kind of wax, wax number 1 and wax number 2, for a total of 40 floors. Now, this middle column here is going to be our sample means. So this is going to be our x bar sub 1, and this is going to be our x bar sub 2. And this is our population standard deviation. Now, when it says population, that tells us that this is lowercase sigma, which is also required when we're doing z-tests. Z-tests have the known population standard deviation. So step 0 is usually used to kind of read over the problem and kind of pick out the important details and make a table. But you can see here in our first example, the table's already given to us. So step 0 is not really necessary since most of the work is done. Now step 1 is going to be to label our null and our alternative hypothesis. Now it says here in this sentence, does the data indicate that wax 1 is more effective than wax 2? So the more effective might be a little relative to what we're talking about here. And it looks like the sample mean number of months the floor wax lasts. So you want to basically have a longer or bigger number. So wax 1 being more effective than wax 2 is going to be a greater than relationship, because we want, after you wax the floors, for the floor wax to last a really, really long time. So our null and alternative, first of all, let's start with the null. This is when the wax average is going to be the same as the wax average of brands 1 and 2. Our alternative, and I'm going to use H sub A so I don't get the 1 and 2 confused here, this is when the first wax is going to be greater than the second wax. Okay, so step 2 for these z-tests go pretty quickly, because you're going to check to see if your sample of the first group plus the sample of the second group is greater than or equal to 30. And that's definitely true, because 20 plus 20 is greater than or equal to 30. So we can assume normality. So there's no check for this. Okay, step 3 is to go to the calculator, and that will get us step 4 and step 5, because step 3 is going to have us do the two sample z-test. So if I click on, and I go to the stat, and click over to tests by clicking 2 over, or I could click 1 to the left, you can see that the two sample z-test is option number 3. Now I'm going to scroll back up to the top here to get my data. Now, we are not going to use any kind of data, because I'm not going to give you more than 30 pieces of total data here, because there would be more than 30 if you added up the first and second sample sizes. So always be sure that you're on the stats part. So click enter here, and now it asks for the lowercase sigmas first. My thought is possibly because they want you to make sure that you have your population standard deviations, which is why they may want to ask for them first. So here's 0.33, and here's 0.36. The average of group 1 is 3, and the sample size of group 1 is 20. Average of group 2 is 2.9. Seems to be pretty close. And then the sample is 20. And I'm going to scroll down a little bit. And in this case, we're not looking for not equal to. We're looking that mu1 is greater than mu2, which makes this a right tail test. And let's go to draw. So we move our cursor over to draw and hit enter. And we have a beautiful normal curve there with a z-value of 0.9157 and a p-value of 17.99%. So I'm going to write down those values here in step 3. So step 3, it looks like my z-value is 0.9157 and the p-value is 0.1799. Now what's nice about choosing the draw function is because we not only see our values we need for step 3, but it also gives us the picture we need for step 4. So we're going to take a look at this picture. Beautiful z-curve. And we're going to have 0 in the middle, which is 0 standard deviations away from the norm. And that middle line means that there is no difference between the two averages, or the two brands. Well, we're going to have to plant our flag here at 0.9157, which means that to get this data, I am almost 1 standard deviation away from the norm. And from previous videos and lessons in this whole course, being 1 standard deviation away from the norm still puts you in the normal zone, which means that our p-value is not a rare event. You had a 17.99% chance of landing in that zone, which means that this is not a rare event. So if we compare our p to our alpha, my guess it's going to be greater than, because our alpha was only 5% and our p-value was 17.99%. Since the percentage chance of us getting this result was greater than making a mistake, we are going to not reject the null hypothesis. So, since this is the required inequality, p is greater than alpha, be sure to write this in your paper pencil homework here, we do not have sufficient evidence to reject the null hypothesis. So you see right there, do not reject the null hypothesis. Okay, so there's the first of 3 examples I will do with you in this video. And let's go to the second problem here. Oh, looks like we've got another problem that has a table, beautiful table for us here. Now what we're looking at, the average RPMs of some engines here, and the engines have standard deviations, and let's both assume normal distributions. So step 0 is practically done for us here, since we have the averages and standard deviations, and the problem did say assume normal distributions, which is nice because we do have a total of 30 engines randomly tested in each group. So that's 30 and 30 for a total of 60. So we are definitely going to easily assume normality. So let's get to step 1 and 2. Alright, so for step 1, we have to look at our null, and our null is probably easiest to basically state that mu1 is equal to mu2, and our alternative, which I'm going to use h sub a, because I don't want to get that confused with engine 1, because sometimes you do use a 0 and a 1 for your null and alternative respectively, but in this case h sub a is easy to understand. Now, it says, does it indicate that engine 2 has a higher RPM than engine 1? Well, it sure looks like it. I mean, 1600 is greater than 1500, but we should still run tests to see if it's statistically significant. So here's our mu1 less than mu2, because mu2 is bigger than mu1. Our step 2, our n1 plus n2 is definitely greater than or equal to 30, because we have 30 in one of the 2 groups, so of course 30 plus 30 is going to be greater than equal to 30, so we can assume normality. Okay, so if you're kind of wondering why some problems on the homework or the XYZ online homework or whatever homework you're using, they don't ask this question, because in Z-tests, even 1 or 2 sample Z-tests, it's usually covered in the problem that you can assume normality based on the fact that it was picked from a normal distribution. So it's time to do your calculator work. So get the calculator out, go hit stat, move over to tests, and then move down to 2 sample Z-test. And again, make sure you're in the stats mode, because I don't think I'm going to be giving you 60 pieces of data to type in. Okay, so the first standard deviation is 50, second standard deviation is 60. The first average is 1500 with 30 pieces of data. And the second average is 1600 with 30 pieces of data. Now we're going to continue clicking down, and in this case we do not want greater than. We're going to change that to less than. So click the enter button here. And move over to draw and click on draw, because this not only gives us our test values, z equals negative 7.0129 and p of 0, it also gives us a picture? Now, what has happened is that this has actually drawn the correct picture. In previous videos, I've mentioned something like this about the resolution of a graphing calculator, or computer for that matter. This z-score is 7 standard deviations below the norm. That is highly improbable. But I'm telling you folks, this is crazy small. Now I want to show you another way if you did the problem instead of the picture, if you went to, and again, this is not following my directions, but if you went to, instead of the graph, where in the draw mode, what if you went to calculate? Now you have something called P177E negative 12. Now, I love this answer because it shows you just how improbable this is. So let's write down our t value of negative 7.0129. And of course, on the z chart, if you try to look up this number, it would be below our lowest number on the chart. So it would say, assume that the score is 0.00001. But let's imagine that instead of writing down the p of 0, you wrote down the p value of 1.17e negative 12. Now you're still just asking, why are you making me write this down? I literally saw p equals 0 on the screen with the graph on it. Well, because I'm getting students from time to time emailing me, still asking what the little e stands for. And the e stands for exponential notation. So what this means is that you take your 1.17 e negative 12 and you move your decimal 12 spaces in this direction. So you're literally putting on 11 zeros because you've used up one of your 12 spaces in this direction. You're putting on 11 zeros in front. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So your answer, or your probability of landing in this little zone way over here, where you have to plant your flag at negative 7.0129 standard deviations away from 0, you have to, their chance of doing that is 0.00000000177, which is close to 0. Okay, so you have like literally no chance that these two would be at ever the same, because this is a rare event that these two engines should be this far off. I mean, if their intention was that these two engines were the same, this is absolutely not the case. So the p-value here, this is going to be 0, close to 0 to call it 0, and this alpha is, I don't care. I mean, 10%, sure, but I mean, it doesn't matter. You can make alpha whatever reasonable amount you want. Step 5 is still going to be, we're going to reject this thing since p is less than alpha. We have sufficient evidence to reject REJECT, reject the null hypothesis. See, we reject the null hypothesis. So I wanted to show that to you just because if you do end up seeing an E on your calculator, that means exponential notation. Although by going to the graph, like I suggested, the calculator does take that really long number and just say, it's 0. It's 0. That 11 place 0, just, yeah, you're close to nothing. Okay, so for our final example here, we get to make a table ourselves. All right, this is going to be good. So for this final example here, which is going to have another kind of odd result, just like the last problem had the result where you didn't see anything on the graph, this one's going to have kind of like the opposite problem. So an interested citizen wanted to know, so hey, in the absence of a table, get ready to read and write as we kind of do this here. As an interested citizen wanted to know if Democratic U.S. senators are older than Republican U.S. senators on average. So Democratic senators are older than Republican. Okay, well, let's see here. On May, now you might, like, I want to read through the entire problem before I get to my null and alternative hypothesis here, so let's just check here. On May 26, 2013, the mean age of 30 randomly selected Republican senators, okay, so I'm going to put an R here for Republican, N sub R is equal to 30. Okay, was 61 years, 247 days. Okay, so this is my X bar R, and that's going to be 61.675 with a standard deviation. So this is my sample standard deviation, although I can use lowercase sigma here. Just because we're going to assume normality, essentially somewhere in this statement it probably says that. It's going to be R with 10.17. The mean age of 30 randomly selected Democrats, so this is D, and D is equal to 30, was 61 years, 257 days. Wow, only a 10-day difference. That's pretty close. X sub D, which is 61.704. Again, really close here. With a standard deviation, okay, here's some difference. We got a standard deviation here of 9.55 years. Okay, so here we go, 9.55. Does the data indicate that Democratic senators are any different than Republican senators? Okay, this is good because now this sentence sets up the null and alternative right here, whereas the first sentence probably would have thrown us off if we got a little too jumpy on that. And then we got an alpha of 5%. So step one, we're going to have our null hypothesis right here, where mu sub r is equal to mu sub d. And of course, since we're using a sample, we're going to assume that if the samples are not rare, then the averages are going to be fine for the population. So h sub 1, we're going to look at mu sub r is not equal to mu sub d. Okay. Now, step two, although it doesn't say assume normality, we can do so if our n sub 1 plus n sub 2 is greater than or equal to 30, which it is, because 30 plus 30 is greater than or equal to 60, so we can assume normality. Well, spelled that one terribly. Get a little ahead of myself. Assume normality. Okay. So, we're moving on to step 3, 4, and 5 with the calculator step. And I promised you a little bit of a weird situation here, so let's actually take a look at this. Let's go to stat, move over to tests, move to sample z test. Okay, and let's go to the standard deviation of the Republicans, 10.17, and the standard deviation of the Democrats, which was a little smaller. Was that enough to tip the scales? Because these averages are pretty close. All right, we got 61.675. All right, and then we have a sample size of 30. This is 61.704, not equal to. All right, so then we're going to go to draw. We're going to go to draw, and we're going to go to draw, and we see this situation. A completely filled in curve? Well, actually, it's not completely filled in. It's actually, there's a little space right around the middle that's actually not filled in. In fact, I will prove it to you because our z value isn't 0. Our z value from the problem itself here, so z is equal to negative 0.014114. You see, if we are at 0 here, for 0 standard deviations below the norm, then we actually have a space between these two, which would actually be mirrored on the other side. So yes, it is true that everything is shaded in. I'm going to use the highlighter function to do this. So everything is shaded in, but there is this kind of white space that the calculator just doesn't have pixel width small enough to show us. But it shows us that these values were incredibly likely. This is the exact opposite of a rare event because this event had a 99.09% chance of happening. P is way bigger than whatever your alpha could ever be. Emphasis added on the greater than symbol here because 0.9909 is greater than 0.05 by a country mile. So since P is greater than alpha, we do not have sufficient evidence to reject the null hypothesis. So yeah, Democrats and Republican ages are the same. So we do not reject the null hypothesis here. And again, always make sure you have your inequality statement as part of this sentence on your written homework. All right, well, thank you for watching this, and we'll do 2 more examples in the next video on 2 sample z-tests.